of chapter 1. I will be doing chapter 1, and I think if I remember right, 6 sections. It may be less than that. Bottom line is I'm trying to do them in small amounts and title them as to what the topic being covered is so that you can go back over and view them. But do them in order, because I'm going to tell you right now, if you do not do them in order, then you may not understand the terminology that's coming in later, and it will be critical. As we go through a section, I will also be working the problems in that section as we go through it. Now, I know we're online, but that doesn't negate the fact that you still need to attend the lectures, aka view them. The advantage is you can view them more than once. All right, so we're going to start chapter 1, matter measurement and problem solving. And again, some of this stuff should seem very familiar to some of you, but I'm assuming that some of you might not have touched anything at all, and I'm making sure we're all on a level playing field. So you're like, yeah, I know that. Fine. Make sure you know it, because we're going to go through it in depth. Now, chemistry, everybody's like, why do I need to study it? If you need it for your major, that's one thing. But in general, why do you need to study it? Well, my statement is are you breathing? Because biology and chemistry are critical. Physics isn't far behind, especially when you're driving. But chemistry is inherently tied in with biology, and there's no such thing as chemical free. And everything you do involves chemicals. So in chemistry, we're going to study the composition of things. What's in it? Are we dealing with something that's organic, inorganic, acid, base, etc.? We're going to look at the structure. How is it assembled? Are we talking about an ionic compound, a molecular compound? And again, a lot of these you're like, what's she talking about? We'll get to these as we go. But we need to see how it's assembled. When you get into biology, they talk about alpha helixes and beta sheets. Again, it's a matter of the structure based upon the chemical properties. And then the properties, how does it look or act? If you have a substance that's going to explode, then you really don't want to handle it. If you have a substance that's going to kill you, if you inhale it, you really don't want to inhale it. So the question is what are the properties? Because some things sound innocuous and aren't, and some things sound awful, phenolphthalein, and are really not that bad. It's a laxative. Don't eat a lot of it. So anyway, we're going to try to put all these together as we go forward. And again, this is a variation on the theme. This is how just a few of the areas that is covered. Medicine, right now everybody's struggling to do coronavirus testing. And we have all of that. We're in summer, so let's look for our lightning bugs. There's a really cool experiment that if Dr. K runs it and videotapes it, I'll get it from him so you can see things glow, because it's just cool to watch. Okay, so throughout the text, you're going to have these, what I like to call little land yaps, or little notices about how things can apply to you. And normally in an in-class test, these are bonus questions. I'm not really going to have these as bonus questions, I don't think. But these are worth reading through, because some of them are more interesting than others. Some of them I'm like, eh. But some of them are actually really good. But it's worth understanding how things apply so that you understand why this is an important course to take. All right. Now, one thing that every scientist has together in common is the scientific method. And this is the way scientists tend to look at things. Now, this is in a closer look, but this is actually really important. We use this all the time. We just don't refer to it. So what do? You make observations. You see something. Okay? For example, let's talk about the chemistry class. Okay, the observation is online is no fun. Okay, we recognize that online is hard. Okay, we're going to develop a hypothesis. So the hypothesis, let's go with more work is needed for an online class. Okay, and some of you have already discovered this. Okay, we'll make a prediction that can be tested, and you can say, I can do this in 3 hours a week. Okay, the result is fail. Okay, why is that? Well, the conclusions is if you only took 3 hours, then you did not view all the videos, because we'll have more than that. And remember, this is an accelerated class. We're doing in 1 week what it would normally take 2 weeks to do. So if you wanted to go on vacation, this is not a good thing to do. Okay, actually right now, they're not letting you, so your life's good, at least for this class. All right. So if you were able to do it in 3 hours and you did not view all the videos at least once, and a number of y'all are going to go back and view them a lot more than that. Okay, so then what we find out is that since we failed, our hypothesis was not supported, so we go back again, and then you could redo it, and we'll say we'll go up to 6 hours. Rule of thumb is basically for every 1 hour in class time, you would need to spend 2 hours, and that's just to hold your own, get a C. We're accelerated, so technically, in a normal class, in the fall we would do 75 minutes. Well, in summer we do double that, so that would be 150 minutes, which is over 2 hours. So, and again, I can lecture that long, but you can't always. So the bottom line is we use the scientific method all the time. Okay, we use it all the time, but we don't run around going, oh, I use the scientific method to do that. Because if you do that, and if you say it out loud, people look at you and go, okay, what a nerd. Okay, I'm okay with that. I am a nerd. I'm good. But bottom line is that we use this all the time, and we'll do an example in just a second. And so the thing about it is if we saw if it wasn't supported, we went back to the observations and went back around. Okay, but if it is supported, then over time we end up with a theory, and the theory is a model that explains the behavior. So, for example, geese fly north in the winter. Well, at least the geese born in the north. Geese fly north in the winter. That's an observation. The reason or the theory would be is because that's where they hatched out, and they return to where they hatch out. Now, why they do that, that's a different theory. Okay, and a law would be a brief statement that summarizes, and I'm going to write this down, past observations and predicts futures, but some of these they're just worded differently, but it says the same thing in your book, online, etc. But I will warn you that there are certain ways that I like to do things, and if you don't do them my way, they were wrong. Okay, and by that I mean I'm not saying there aren't more than one way to do things, because there are. However, there are certain ways that appear to be will work but really don't all the time. So be very careful if you follow a different methodology. You go to Khan Academy, you go to any of the other sites that are open. Bottom line is, if it comes down to me or them, I win. Okay. So again, a law is a brief statement that summarizes the past observation and predicts future events. So we were doing the geese, the theory is they're going to go home to where they were born, hatched out. Okay, hatched out, they're not born. So the law would state that animals tend to return to their birthplace if they are birds. I'm making that up. That may not be true. So don't rat me out to Dr. Sherry. If you actually want to know the answer to the bird question, then go ask her. But a law would be predicting. So we were doing it with geese, and then we would say that we could predict the same thing is true of rufous hummingbirds. Okay. Again, making stuff up there, etc. So let's work on a couple things that are actually using the scientific method in a way that we can wrap our brains around. So if we have a problem, our cell phone won't charge. Propose a hypothesis to explain, and then design an experiment. Okay, so a hypothesis is a thought process, is what's going on, and then your experiment is what you're doing. So we have several solutions. There are infinitely many, but I picked three. The charger is not the correct one. Okay, so check the fit. I don't know about y'all, but I have thousands of chargers at my house, and it's a running joke as to which charger fits what. So if that's not the right charger, then it won't fit. That's your experiment. If it fits, then you move on. If it doesn't fit, you change it out. Okay, hypothesis 2, the charger is dead. Okay, and this is easy. Try a different charger. And I've got a couple chargers that have died on me. The cords, and I'm thinking, I paid good money for that. But they do die for whatever reason. And so if you try a different charger, that would be the experiment. And if it works, then your hypothesis is proved. Throw away the charger. If it's not, you move on to another one. The battery is dead. Okay. And so in this case, this is a bigger issue. So if you try the charger on a different device and it works, then you know that there's something wrong with the battery, etc. Now, there are infinitely many other options, but what we did was we came up with a hypothesis, then we planned an experiment and we tried it. If it worked, then we closed the loop. If it didn't work, then we went back and looked at our observations again and drew a different conclusion, made a different hypothesis, and checked it. And again, scientific thinking you use all the time. You just don't run around going, oh, I just used the scientific method. Okay? And as I said, you use it all the time. You probably used it today already, and you just didn't think about it that way, and that's fine, but I need you to think about it this way when you're in a science class, my class, or physics, etc. Okay? Now, we have one last slide in this section, and this one is dealing with terminology that will pop up a lot. And so you need to know the difference. And we have 4 terms: qualitative, quantitative, extensive, and intensive. They're kind of paired. Qualitative goes with quantitative, and extensive goes with intensive. And they kind of are the same thing, but said differently. So what is this? Qualitative, it depends upon the quality, whatever it is. So it's independent of amount, and it's descriptive. No numbers. So, for example, it's a red ball. It's a green ball or a green cube. Okay? So, that's giving you a color and a shape. Quantitative, on the other hand, is dependent upon amount. And I use a lot of abbreviations, and I will try to either limit them or explain them as we go. And the other thing about quantitative is we're dealing with a quantity. So it has numbers. Okay, so here, if we went back up here, we would say 3 red balls and 4 green cubes. That would be the quantitative part of the whole thing. So here, if you combine it, we have qualitative and quantitative. Okay, extensive is similar to quantitative in terms of it is a function of the amount present. You know, to what extent did you do your work? There's an amount. You did most of it, a little of it, a lot of it, whatever. Okay, this is usually a mass, volume, length, some sort of quantity. Okay, Okay, whereas intensive, again, is independent of amount. And if you'll notice, qualitative and quantitative we use pretty much in descriptive. Extensive and intensive we're going to use in the chemical terms. So independent of amount present. And just like extensive uses mass, volume, etc., intensive is going to be things like color. We saw that before. But density, things that don't matter how much you have, like the boiling point, the density doesn't change. And there are a whole lot more. So when we talk about properties, we're going to talk about whether something is intensive, extensive, whether that was a qualitative or a quantitative description. And again, they're kind of the same, but one of them is a little more technical than the other. So as I walk through things, we'll work some problems, I believe, in the next section. But right now we're going to stop at this point. This is part 1.